Okay, question 13 then. Diagram shows part of the curve with an equation of y equals x3 minus 6x squared plus 9x. Okay, curve touches the x-axis at A, has a local minimum of B, local maximum of B. Show that the equation of the curve may be written as y equals x and hence write down the coordinates of A. So we are wondering, can we show that this is the same as x minus 3 squared? Well, if we take this, we can say it's equal to x, and factorizing out the x, we get x squared minus 6x plus 9, and then looking at that, we can take the factors out of it, and we can say it's x minus 3 and x minus 3, because the two x's give us x squared, minus 3x gives us minus 6x, and minus 3 times minus 3 is 9. So we end up with x minus 3 squared. Okay, so with that done, hence write down the coordinates of A. So in which case we take the x minus 3 because it's the repeated one, and we say that's equal to 0, and so x is equal to 3, and so A is x of 3 and 0. Find the coordinates of B. So to find coordinates of B, we are going to find dy by dx. Okay, and we are going to differentiate this. So we are going to drop the power and divide and multiply by the whole power. So we are going to get 3 times x squared minus 12x plus 9. And for that, we're going to set it equal to 0. 3x squared minus 12x plus 9. And we are then going to say, what's the solution to that? Going to use the calculator to do the solutions for that. And so, nope, that one. Let's go have a look. Okay, polynomial number 2. Here we go. 3 minus 12 and 9, and we get x equals 3, which will be the solution up here, and we also get x equals 1. Looking for the coordinates of B, so we are looking to put x equals 1, so when we do f of 1 on the original equation, we get 1. I'm going to use the factorized version because it's going to be quicker. So 1 minus 3 is minus 2. Minus 2 squared is 4, meaning coordinate B is at x of 1 and 4, which matches with the picture that they have given us. Okay. Finally now, the shaded region is bound, so we need to do the integral between 3 and 0 for the original equation of x cubed minus 6x squared plus 9x. So we're going to be doing x to the power 4 divided by 4 minus 6x to the 3 divided by 3 plus 9x squared divided by 2. Okay. between 3 and 0. So we have got 3 to the power of 4. 4 minus, what's that going to become? It's going to become 2. 2 times 3 to the power of 3 plus 9 over 2 times 3 squared. Take away, that's a 0, that's a 0, that's a 0. Take away 0 on all of them. So coming back into here then. So 3 to the power of 4 is 81 divided by 4 is 81 over 4 minus, what's that, 3 to the power of 3, that should be 27, times by 2, 54, 9 9 9 is 81, 81 over 2, okay, and all of that, let's see now, 81 divided by 4 minus 54 plus 81 divided by 2, 27 over 4, 6.75. Is that what I just saw? Yeah, 6.75. All in. Right then, let's have a little look at what this one is. Question 14. So we are told that y is equal to 3x to the power of a half minus 4x to the power of minus a half. X is greater than 0, find dy by dx. Dy by dx is where the power goes smaller and you multiply by the whole power. So we have 3 over 2x, and it becomes minus a half, minus 4 times minus a half is plus 2, x to the minus 3 over 2. And also they want us to find the, what's this one we're doing? 14. 3 over 2x to the half and 2 3x. Yeah, okay, that's grand. And then they also want us to do the integral of y. So the integral of all of that, where's it gone? 3x to the half minus 4x to the minus a half. So increasing the powers this time. So we have 3x to the 3 over 2, and we now divide by the new power. So we'll be multiplying by 2 divided by 3 minus 4x to the half, because minus a half plus 1. Okay, dividing by 2 over 1, which is there, plus c. And so finally, we are multiplying that out. What do we have there? 2x to the 3 over 2 minus 8x to the half plus c. Okay. Got the minus. Good. All right. And finally, what did they want? Hence show that they now want the integral between 3 and 1 of y dx, and they want to see it in the format of a plus b square root 3 and find ab. So we can go straight in there with the integral of 2x 3 over 2 minus 8 x over half for 3 and 1. 2 times 3, 3 over 2 minus 8 times 3 power over half minus 2 times 1, 3 over 2 minus 8 times 1 power over half. You notice I always leave my minus on the outside and change all the signs afterwards. Alright, so what do we have there? We've got 3 to the power of 3 over 2, which is like 5 point something, and this is where the calculator doesn't come into its own. Okay, so what are we doing there? We are cubing it and we are square rooting it. Okay, so 3 cubed. In fact, let's leave it like that for the moment and see what happens as we take it out. Because ultimately we're trying to get it in that surds form. Let's just quickly see any of these. 3 8's 24. Square root of 3, yes, nothing's coming out on here. This one is just 2. This one is just 8. So 2 minus 8 is minus 6. Minus 6 is plus 6. So we have plus 6 here, plus 6 here, and for this one, let's decide what we're going to do with it all. We can take a 2 out. Okay. I feel like we can take a 3 to a half out here as well. Yeah, so if we do a 2 and then a 3 to the power of a half coming out, we are left inside here a 3 to a third minus 4. Okay. 3 to a third is 27. Is that right? 27 minus 4, 23 times 2. 46. So I think we've got 6 plus 46 root 3. I think. That's not right, is it? If I do that, if I take a half away from 1.5, I am left with 1. Which means 3 take away 4 is minus 1, minus 2. So that should be a minus 2. Yeah, that looks better. So A equals 6 and B equals minus 2. Getting all my roots back to front and upside down today. Alright, question 15 then, finish off this video. Question 15. Diagram shows sketch of a curve which has y equals 12x to the half, okay, minus x to the 3 over 2, okay, and we work between 0 and 12, okay, show that dy by dx is this. So, dy by dx is where we drop the power multiplied by the old power, so it becomes 6x to the minus a half, okay, minus 3 over 2x to the half, alright, and we are trying to get this now into the equation of, what does it say there, 3 over 2x to the minus a half, open brackets, 4 minus x. So we're taking 3 over 2 out. What is 3 over 2? 3 over 2 is 1.5. How many 1.5s are there in 6? 4. Okay, so taking the 3 over 2 out, we are left with the 4. Taking out the x to the minus a half, grand, minus, that one's gone. Now then, if we have done that, we have got x to the power 1, because you are taking away, you are doing x to the half, take away the minus a half, which gives you 3 over 2 x to the minus a half 4 minus x, which is what they wanted. Okay. With that done, we can look at the point B on the curve. The point B on the curve, the tangent to the curve is parallel to the x-axis, making it a maximum. Find the coordinate of B. So because of that, we can set this to equal to 0, because it's a maximum, and we can then solve for x to the, what is that? Is that half? Yeah. Minus a half x minus 4. Okay, so solving that, we end up with all of this bit can be divided by itself and is so gone, and so we end up with 0 equals x minus 4, so x is equal to 4. Okay, we can then put that into the original equation, which was the 12x to the half minus 3 minus x 3 over 2. And we're substituting the 4 in here, so we're doing f of 4 is equal to 12 times 2 minus 2, it's about 8, isn't it? 4 to the power of 3 over 2, 4 to the power of 3 over 2, yes, it's 8, and that's 24 minus 8, gives us 16, making point B an x of 4 and a point of 16. Okay. Finally, find to 3 significant figures the area of the finite region bounded by the curve of the axis 6 marks. So, we haven't done any integration yet, so let's integrate this part C. Integrate 12x to the minus a half minus x to the 3 over 2 dx, and we're going to be working between 12 and 0. Okay, because that's what's marked up on the graph in terms of where it is bound. Okay. So integrating that, then we end up with 12x to the 3 over 2 being multiplied by the 2 over 3 minus x to the 5 over 2 being multiplied by the 2 over 5. 12 and 0. 2 times this is 24 divided by 3 is 8. So we end up with 8x, which is now 12 to the power 3 over 2 minus 2 times 12 to the power 5 over 2 divided by 5. Take away 0. 12 to the power of 3 over 2 is 41 point something times 8 is 33. 332.5537 minus, what do we have there, 12 to the power of 5 over 2, 496, times by 2, 997.66, divided by 5, 199, what's that, 5322. And so when we do the takeaway on that, 322, no, 332, 55375, take away previous answer, we end up with 133.021, and so 133 to 3 significant figures. Might be worth, with one that goes as long as that, to just use your function on the calculator. Okay, since you're doing it between the limits, you can go straight into it and typing it into the calculator, 12x to the power of a half. Okay, minus x to the 3 over 2. And we're working between 0 and 12. And straight into the calculator. Ooh, that's got it thinking. Really is making the calculator think, that one. That's why I pressed clear. Okay, but we know the answer is 133. All right, good. That was question 15. We've finished that exercise